In this video, we're going to graph linear inequalities. So we have inequality symbols we're going to be using in this lesson. We have the less than or equal to or greater than or equal to signs, and they make a solid line on our graph because they have the equal to bar. So that means it's equal to the line. Or we are going to use a dotted line for our graph when we have less than or greater than as our symbol. So our steps are that we're going to graph the line like normal, so using slope-intercept form, or we're going to solve and put it in slope-intercept form first. We're going to choose whether we need a solid line or a dotted line, and then we're going to shade in the direction that goes along with whether it's greater than the line or less than the line. And just remember, if you divide or multiply by a negative number, you have to flip the sign. Okay. It also says we could pick a point to help determine which way to shade, so we'll do both ways. So let's graph each inequality and name two solutions. So in this first graph, we can already see it's in slope-intercept form, and we can see that our slope is 2, which is 2 over 1, and the y-intercept would be 1. So let's write those down, and then we'll graph them. Let's label our x-axis and our y-axis. And then let's put the y-intercept at 1. And then using our slope, we're going to rise 2, so go up 2 and run 1. So 2 over 1 gives us another good point on the graph. And then we can draw a dotted line or a solid line. So you don't want to just draw any line, you want to look and see which one's appropriate. So this says y is less than this line. It's not equal to. So I'm going to make it a dashed line going through my points. And what might be helpful is to graph a few more points, actually. So let me back up. You can use your slope to graph more than one point. So if I go 2 up to right 1, I could do it again. I could go up 2 more and right 1 more and get another point. And then I can go the opposite direction and continue to go in the same pattern to find me another good point in the other direction. And then connect them all with dashed lines, but that might help you know exactly where to draw it on your graph. Okay, so then we don't have to use these guide marks. I'm just drawing them for our notes. But we have this line, we have some arrows on the end, and we need to know where to shade. So you can pick a point on either side of the line to test out and see if it makes sense. So in that case, if I pick the point 1, 1, for example, I want to see is that part of my solution set. So I would just plug it into my function. So that means x equals 1 when y equals 1. So I'd say 1 is less than 2 times 1 plus 1. I just substituted the 1 for the y and the 1 for the x. And then I have to see if this statement is true. Is 1 less than 2 times 1 plus 1? So 2 times 1 is 2, and then plus 1, so is 1 less than 3? And it is. So 1 is less than 3, so that means that that point is part of my solution set. So that means I would want to shade on this side, because these are where my solutions to this line are going to be. And that's where that point is, and it worked. So that is a great way to know where to shade your line, your inequality. Okay, so it says to pick two solutions. So now that I know that's one of them, I'm going to write that down. But now I know all the points over there I've shaded would work. So I'm just going to pick another point out, like, let's say 2, -3 is also in the solution set. So let's put and 2, -3. So 2 good solutions to that inequality. All right, let's look at another example. So number 2 is in slope-intercept form already. Y is greater than or equal to 1/3 x minus 2. So I see I have a slope of 1/3 and I have a y-intercept of -2. Okay, so let's label the graph. That's my x-axis, that's my y-axis. I've got a y-intercept at -2, so let's put a nice point right there. Then using a slope of 1/3, I need to rise 1 and run 3 to get another point. Then let's do that again. Let's rise 1 and run 3 and put another point. And then we can go in the other direction. So go over 3, down 1, because we're going in the opposite direction now. Then we're going to go left 3 and down 1, because left 3 and down 1 are two negatives, which really still equal a positive on our graph. But now that we've got all these good points, we don't have to use our guide marks. So I'm just going to remove those. And then I see that my symbol is greater than or equal to. So that means my line is going to be solid this time. So I can make a nice solid line. Then let's pick a point on either side, because when you test it, you'll either know it's part of the solution or it's not part of the solution. So I'm going to choose 1, 1 again, because that's a pretty easy one to plug in. So that means x is 1 where y is 1. So I'm going to plug it into my inequality. So I'm going to say y is 1. Is that greater than or equal to 1/3 of 1 minus 2? Okay, so let's clean that up. Is 1 greater than or equal to 1/3 minus 2? But I can't subtract without a common denominator, so let's do a little work. That's 2 over 1, so I need to multiply the top and the bottom of that fraction by 3. So then is 1 greater than or equal to 1/3 minus 6/3? So let's see, is 1 greater than or equal to, and that would become -5/3. So is 1 greater than or equal to -5/3? And we would say yes, that is true, because 1 is definitely greater than or equal to a negative number. So if that is part of the solution, then we want to shade it over there where that point is located. So let's shade everything over here above the line. And let me show you another way you know where to shade these lines. This is another good way, but notice that point took a little work to plug that in. So the other way you can look at this is the greater than or equal to sign means that when it's in slope-intercept form, that it's going to be shaded greater than, which is above the line. So notice here's my line, and here's everything above the line. So it's a quick way to know where to shade it. And you can always test a point out if you like that method too. And we needed to know what two solutions are anyway, so now we've already got one is 1, 1, and we know everything above the line would work. So let's just pick out like -2, 2 would be another good point to label. Okay, so let's do another one. So what if your equation is not in slope-intercept form and you just got to do a little work first? No problem. We've talked about that before. So let's move the x term. So we're going to subtract x on both sides. And we would end up with, I'm just going to write it over here, -2y would be greater than -x minus 4. And then we've got to divide out the number in front of the y. So let's divide everything by -2. Then we're going to get y, but we've divided by a negative. So you've got to switch the direction of your inequality now. So it's now going to be y is less than 1/2 x plus, because a -4 divided by a -2 is going to be a +2. Okay. So just in case that's in the way of your graph, you feel free to write it over here. So we just had to change the direction of that inequality symbol because that was from dividing by a negative. So when you divide by a negative, think about it changes every sign in your inequality, including the inequality symbol. And then we need to pick out our slope, which is nice and easy now. That's just the 1/2 in front of the x. And then our y-intercept is going to be +2. So let's label the y-axis and the x-axis like we've been doing. And then we're going to plot our y-intercept at +2. And we're going to use our slope to graph some more points. So we got to go rise 1, run 2. So up 1 over 2 will give us a good point. Then do it again. So rise 1, run 2. And then we can do it again. And then we just go the other way. Oop, wrong color. So let's go left 2, down 1, because that's just going in the opposite direction to get some more points. So left 2, down 1. And you can kind of tell on your graph that's the way it should be, because it's going to be a straight line. It's not going to have a zigzag in it. Okay. So then we need to know, is it going to be solid or dashed? So you look right here at this symbol now. It's less than, but not equal to. So we need to make sure it's a dashed line. And then to shade it, you can think of the fact that this is just less than, that's the symbol. But if you get confused about which symbol is which, you can certainly plug in a point. So let's just plug in the point 0, 0 this time. So you want to plug in the x is 0 and the y is 0 into slope-intercept form that we've got right here. And you can also, actually, you could plug it into this form because they should be the same. All we've done is rearrange things. So either one should work. But I'm just going to plug it in that slope-intercept form I've already got over here. So 0 is less than 1/2 times 0 plus 2. We want to check and see, is that true? So is 0 less than, and then 1/2 times 0 is 0 plus 2. So is 0 less than 2? And it is. So each time so far, we've ended up on the right side of things. So let's shade over here. And it's less than, so it should be shaded below the line. It's just the other way to think about that. And then let's write down our solution and one more solution that would be in that shaded area. So 0, 0, and let's pick out 3, 1 is another good point. Okay. So that is 3 good examples to get you started on graphing linear inequalities.